Welcome to the new session. In this session, we are going to discuss about the different type of inputs or forcing function. So in process control systems, the disturbance, the inputs are called as a disturbance. The outputs are known as the response. So what are the disturbance are also known as the input function. So we are in this video, we are going to discuss about the what are the different type of input function or forcing function that usually occur in control system. So we have mainly, we are going to discuss about the 5 type of inputs, that is step input, impulse input, sinusoidal and ramp input. So first we will see the what is the step input or step function. So the step function, it has a Laplace form of x equal to 0 when time is less than 0, x equal to a when time greater than or equal to 0. That is the Laplace of x of s is nothing but a upon s. So that is the step input Laplace form. The step input Laplace form is a upon s. So now what is step input? We'll see with some example. For example, everyone we know the steps every day we are seeing in our home. So the steps has the equal magnitude. So in step input, we are step by step, we are giving the disturbance. For example, if you take a pipe flow rate, the flow rate is increased by first 1 meter cube per hour, then 2 meter cube hour. So like that, step by step, you are disturbing the process. That is known as the step input or step function. So we can take another example. Take a temperature path. In the temperature path, step by step, if you are increasing the temperature, first 1 degree, then 2 degree, then 3 degree, then 4 degree. So step by step, if you are giving the disturbance, that input is called as a step input or step functions. The step function has the graphs like that, the time in x-axis, x of t in y-axis. So capital A is the magnitude. So here the step by step increase in the disturbance will be given to the step function. So now coming to the second function, what the second function is the impulse function or impulse input. So what is the impulse input? So we can say in other way, the impulse input is nothing but the time independent input. For example, if you take a path, temperature path, just immerse a thermometer, then suddenly remove the thermometer. So what will happen? The impact of temperature path to the thermometer will not be there. Like that, if you suddenly open and close the pipe valve, then what will happen? The flow rate is not that much affected to the process. So that kind of input, we call it as a impulse input. So what is impulse input? The time impact will not be there. Sudden immersing and removing is the best example of impulse input. So the impulse input has the Laplace form. It is x of t is equal to EA. So here x is 0 when time is less than 0. X equal to a by b when time is in between 0 to b. So what is the b? I think you can see in the graph. Okay. So what is a? A is a magnitude. So b is this distance. So a by b we can take it. So now what is the lambda of t? The lambda of t is the impulse function. Okay. The time independent function. So it's denoted by the lambda of t. So that is the impulse function. Now we coming to the third type of input, that is a sinusoidal input. So what is a sinusoidal mean? You maybe heard about sound or water waves. How it's going, number of cycles. Okay, number of cycles per unit. So that kind of input we call it as a sinusoidal input. So in the sinusoidal input, the x of t is a sin omega t when t is greater than 0. So what is the Laplace form of x of s? That is nothing but a omega divided by s square plus omega square. So a omega divided by s square plus omega squared is the Laplace form of the sinusoidal input. So now coming to the other type of input is the ramp input or ramp function. So what is a ramp function? So the ramp function will be changing linearly with respect to the time. So the ramp input, for example, if you are going to increase the path temperature linearly with respect to the time, for first 1 hour, the temperature will be 2 degree. For next 1 hour, the temperature will be 3. So like that, with respect to the time, if you are increasing linearly or if you are disturbing the path linearly, that type of input we call it as a ramp input. So ramp input is generally a time dependent input. Now coming to the next type of the input is the exponential input. So what is exponential input? The x of t is e power minus at. So x of s is 1 upon s plus a. If you take exponential input, there are two type it is there. One is exponentially decreasing, another one exponentially increasing. So if you take e power minus at, that is exponentially decreasing. E power plus at is exponentially increasing function. So these 5 type of function, or call it as also known as the disturbance. Okay, step, impulse, ramp and sinusoidal exponential. So these are the 5 type of inputs we generally study in the process control system. Now we'll see the response equation of first order system with a different forcing function. So what is the response equation? Okay. So now take a general form of first order system. Any first order system will be in the form 1 upon tau s plus 1. This is the general form of any first order system. We know here the tau is nothing but time constant that vary from process to process. Now you take the step response of first order system. Here the y of s is output, x of s is input. So y of s is also known as the response, x of s is nothing but the disturbance. Now what kind of disturbance we are giving is a step input. So x of s equal to a upon s. Now input your input function to the original Laplace function. Here what is x of s? X of s we have given is the step input. So a upon s. Now this is the Laplace form of first order system with step input. Now what we have to do? We are going to determine the response equation. So what is response equation mean? We need to get y of t from the y of s. So what is y of s? Y of s will be in the form of Laplace. Y of t will be in the form of original function. So now how to get it by y of t? By partial inversion by partial fraction method. So what is inversion by partial fraction method? Look at the problem here. So a into 1 upon tau s plus 1 into s in the denominator. Okay. So the power of s is 2. So the roots of s also different. So introduce two constants c1 and c2 in the numerator, and you can write like this. Now you can take LCM. So if you take LCM, c1 into tau s plus 1, c2 s you will get. So now if you look at the equation, both denominators are same, so you can equate the numerator. So in this numerator, substitute different value for s. Suppose if you take s equal to 0, you will get c1 as 1. Put s equal to minus 1 by tau, you will get c2 as minus tau. So substitute both constant value in the equation 1. So you will get the form 1 by s plus minus tau divided by tau s plus 1. So now in this equation, we wanted to take a Laplace inverse. If you are going for, before going for Laplace inverse of anything, it should be compared with the standard form. We have the Laplace inverse for 1 upon s, like that. We have Laplace inverse for 1 upon s plus something. So in order to remove the coefficient of s, both numerator and denominator just divide by tau, you will get the form like that. So now you take Laplace inverse of this equation. So what is the Laplace inverse of this equation? So Laplace inverse of 1 by s is 1. Laplace inverse of minus 1 by s plus 1 by tau is e power minus t by tau. So this is the response equation of the first order system with the step input. Now you can have one doubt. What is the use of this response equation? Where we are going to use? For example, if you come to know the first, this is the first order process and the step input or step disturbance occur, one can use directly the final response equation. So what is the final response equation of first order system with step input? That is y of t is equal to a into 1 minus e to the power minus t by tau. So now what is the use of this equation? This equation will give the relationship between the output variable with respect to the time. For example, if you wanted to maintain a temperature in the path as constant at particular time, what is the output? You can come to know by using the response equation. So this response equation will give an relationship between output variable with respect to the time. If you come to know the value of tau, time constant, at particular time, you can know the output of the any process. So the response equation will be helpful to determining the output at any time. So that is the response equation. Like that, if you are applying an impulse input, we know the impulse input formula, exponential, ramp, and sinusoidal. You will get all response equation. So you can derive 5 response equation of first order system. What is the use of response equations of first order system? It will give an relationship between output variable with respect to the time. So at particular time, one can determine the output. By that, you can come to know the process variable conditions. So that is the response equation of first order response equation uses. So now I think in this video, like that, you can derive the response equation for any type of input with respect to the first order system. So in the first order system, I think by using the equation, the final response equation, you can solve many problem. Either time which at the output variable also you can determine, or for example, sometime the output variable will be given at that output variable. What will be the time also they may ask. Okay. So both the thing you can determine by using the response equation. So in this response equation, the tau is the time constant. It has the same unit of time. Okay. Thanks for watching this video. Thank you very much.